So what about the biomass, sir?
Yeah, but that may not be available everywhere. Biomass maybe it may have a very limited capacity also. Okay, it's for country. You can try, but it may not be possible to supply to the whole country.
Limited amount.
Yeah, limited amount. It can have. It will be depending upon their source of biomass.
Household purpose.
Hmm?
For household purpose.
Household purpose. So every of these methods have their pros and cons. Just sun is not available in the night. Wind may be fluctuating. Okay, large hydro needs water. Suppose there is no rain, then what the hydro will not work. If there is less rain, okay, it will affect the hydro. So when it is actually a challenge to find the optimum mix for a country like India. But one thing
Sir,
I found is if you can just reduce this wastage, just reducing the wastage is going to have an enormous gain, enormous effect. Yeah.
sir, in the mechanism of windmill, is it mandatory to rotate the wings in a particular direction?
That will be there. To rotate the wheels in a particular, the wind direction will decide the rotation.
There is no problem if it rotates one time clockwise or another time anti-clockwise.
Sir, then it
No,
would be AC, right?
it is AC, but in the AC you need to rotate in a particular direction. So you in the mills, the wind mills, they are actually directed in the direction of the wind only.
Oh, in a single particular direction.
Yes, yes. They are. If you go to Jaisalmer, you will see them that they are kept. They know the weather. To erect those windmills, they have to first talk to the weatherman. Okay, what is the direction of wind, and also they have to keep it in that direction.
Sir, the rectifiers, what about the rectifiers can help in this case?
The rectifier, those things are there. Once it is AC, you convert it to DC by rectifier, and then the DC you convert to again to AC. All those things will be there. All those technologies are there.
Yes, sir.
And another
Sir.
thing is, yeah.
Sir, thermodynamic efficiencies are too low. Then why still coal and steam are still used extensively?
Because there are a lot of them is available in our country. And in our country, whatever is the demand, we have the other sources still are not to that extent to supply that demand. There are other sources are gradually picking up. As they are picking up, then we will reduce the coal.
Sir, what is
Okay.
the mechanism behind biomass, sir?
Biomass you have to study. It is biological mass like gobar gas and all those things to generate the energy, or any any agricultural product if it can be used for
Which
uh,
which form of energy is converted into electrical energy?
but ultimately it is the energy in the uh, which is the result of photosynthesis that is converted to energy. If you consider a agricultural product,
Photosynthesis, but in gobar gas, how is the photosynthesis is possible?
no, I'm talking of like in many places there is this but ultimately it is the burning of carbon, in carbon in whatever form it is, whether it is inside a vegetation or in a gobar gas. It is the burning of carbon that is used to generate the power. Now, is it visible? Hello.
Yes, sir.
Yes,
Yes,
sir,
sir.
it is visible.
Yes, sir.
Yeah. So so this is basically the schematic diagram of a generation, transmission, and distribution. As I told, we have discussed different types of generation. Okay, so the generation, this top part is basically it happens inside a power station. It could be a solar, it could be a thermal, it could be hydel, nuclear, many things we have discussed. So that is basically the generation. It is called generation. And that generated power is transported through, first it is passed through some equipment which is called power transformer. Okay, and then it is passed through the transmission lines. There are huge transmission lines. And then then there are transmission substations. You will find different substations. When you travel by train, you will find substations. And then through these local, this type of transmission systems, to the distribution substation, to the distribution substation, they go to the different types of consumers. The consumers can be different types. They can be the local, the residential houses. They can be the schools. They can be the hospitals. They can be some factory. So that is that. So that is basically the electrical arrangement in a whole country. First, you need to generate the power. Then you need to transmit. Okay, so you need transformers, and then there is lot of circuitries involved, because everywhere it is the wires involved. And then the wires you see in the distribution, the wires get distributed. If you consider your own locality, you will find the power is coming and it is distributed in the locality. And then there are the consumers. The consumers are of different types. They can be the domestic consumer, they can be the hospitals, they can be the malls, they can be the schools or railway stations. They all are different types of consumers. Okay, so you have to provide, the power supply company has to provide all types of consumers. Is it understood, this diagram?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So
sir.
the power supply
Yes, sir.
company has to,
Yes, sir.
Yes, sir.
yeah,
Yes, sir. Yes, sir.
so if you make suppose you make a new house, okay, you will always need an electric connection. So you will give an electric application for electric connection to the power supply company. Basically, you will give the electrical connection application to something called the distribution company. Okay, so in a electrical system, basically there are different types of companies involved. Some of them are generating companies, that is, they are only generating power. They are only generating power and selling out that power. Okay, just like some of you know the name of NTPC. Okay, CESC, DVC, then NHPC, the National Hydroelectric. Yeah. Yes.
Sir, what is the function of distribution automation devices?
Okay, I will tell. I will go come back to your. Okay, I just tell complete these Gencos and all. So there are companies that are just generating power and they are selling it. Then there are companies that will actually need to transport that power. Okay, who are actually maintaining all these overhead lines, all these overhead transmission towers, huge transmission towers that you see. So they are only taking from that power companies, generating companies, and and transporting it, maintaining all these lines. So those are basically called the transmission companies, or in engineer or in industrial language they are called transcos, which is called as the power grid. Similarly, the power, so they just handle and ultimately they give that power to the distribution company. Okay, say which are known as discos, distribution companies. Okay, and so one example is the BACS, Bombay Suburban Electric Supply. Okay, they are basically a distribution company. They don't have their own generating stations or own transmission lines. They take the transmission lines from they take the power from the transmission company, and then they distribute they do business in the Bombay city. Okay, distribute power. They give a connection to the local customers, the domestic customers. They give connection to maybe the airport, the railways, the hospitals, the port, everywhere. They do the distribution of the power, and they are the persons who actually collect your electric bills. Okay, so once we make a house, we basically approach some distribution company to provide that power, and they will charge you. Okay, somebody asked about the distribution automation devices. Yeah, those details we are not going in these devices, because all this, as you see, that everything is connected. The power station is connected to the power transformer. Every power transformer is connected to the transmission line to the distribution system and all. So, running this, to run this, you basically need a lot of information. Okay, so like the power station, suppose what happens in the power station, suppose they burn coal. They are burning coal. So that information is required here, that they need to provide the energy. They need to provide the energy, or they need to reduce the energy production. Okay, so the whole system has to be automated. So there has to be some sensors, some instruments here that will actually measure the amount of energy consumed here, and that information has to go back to the generating station. Okay, if there is no requirement, then the power company will not burn coal. You understand what I'm telling? Somebody
Yes,
asked
sir.
about.
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
everything is automated. If there is no requirement, we have one type of requirement in the daytime, we have one type of requirement in the night time, we have one type of requirement in the morning. So this requirement actually keeps on varying throughout the day. Okay, and so as they keep on varying, they need to burn different types of fuel, and that information has to go. Otherwise, they will keep on burning only. So all these lines are basically automated, and that information has to go there. That then they will burn less fuel. Just if I tell the case of, say, IIT Kharagpur. So right now all these online classes and all the 25 hostels are basically empty. Okay, you all have been allotted some hostel, isn't it? All of you have got your hostel?
Yes, sir.
Yes,
Which
sir.
all?
LBS.
Yes, sir.
Yes,
Yeah,
sir.
LBS.
LBS.
All
Yes, sir.
All LBS.
LBS,
Indira Gandhi also.
Yes.
Indira Gandhi.
Okay, LBS, Indira Gandhi, and the other Mother Teresa, all these halls are
LBS.
there. So right now all the halls are empty. So all the halls are empty means there is basically no power requirement here. There is some power requirement, whoever is for the faculty staying here or the departments running. But if all these 15,000 students come, there will be suddenly a requirement, because all the rooms will be lighted, all the playgrounds will be lighted, all the gymnasium will be lighted. So that information has to go to the power station. So you need all these type of automation devices. It is all automatic, not that IIT will start making a phone call to the power station ki now you start burning fuel because all the students have come. Okay, and this will take place round the day, throughout the day. Even in your hostel, there will be one type of requirement in the daytime. In the daytime, you are all in the classes. In the night time, you are all in the hostels. And then sometimes you will be in the Netaji auditorium. Okay, sometimes you will be in the football ground. Okay, sometimes you may be in the swimming pool. So the requirement will keep on varying. So that entire requirement has to be transmitted to backwards for better management of the network. If something goes wrong, then only there will be a collapse, as it happened, as somebody told, in 2012. Okay, so these things has to be automated. We don't have a human being sitting everywhere to pass the message to the next layer that this is the requirement. So does it answer the question? Somebody asked about the distribution automation.
Yes, sir. Yes, sir.
So everything is automated. You need, and for automating, you need basically sensors, and again these are all automated through computer-based systems. Computers are used in a big way to make this automation faster, accurate, and more reliable. So this is basically the schematic diagram of a power system, where there is generation, there is transmission, and distribution. Generation involves all the generating systems that I just now discussed: solar, thermal, hydel, and so on, nuclear. Then I've discussed about the transmission, the requirement, because the power station may be somewhere, the requirement may be somewhere else. So you need long transmission lines which are several thousands of kilometers long, which may be. And ultimately, once it reaches, suppose that power from the solar plant in Jaisalmer may reach Kharagpur. So it will basically need transmission lines to transmit the power. And ultimately, at the local level, you need all this distribution. So there are different types of companies, the generating companies that generates. I've just named a few which I remembered, but there are maybe many more actually. There are actually many more. Similarly, the transmission company is Power Grid India Limited. Similarly, distribution companies, I have given just one for Bombay, but there in everywhere there will be different distribution companies. What is the time now?
4-5, sir.
4-5.
4-5. So
4-2.
let us stop the class today.
Sir,
Okay, let us stop the class
Hello?
today.
sir,
Yeah. Yeah, tell me.
sir, I want to ask you
Tell me.
one more question, sir.
What is your name?
Sir, my name is Anil Jyoti.
Okay.
Sir, why don't we store thunderstorm lightning energy? Because it can generate a huge amount of power.
Obviously, you are correct. It can generate huge amount of power, but you
It
don't
is
know.
very uncertain.
We need to harness it now. We don't have the accurate means to harness it.
We don't know whether it will happen, when it will happen. You don't know. It may not happen for the whole year also, and suddenly it may happen. And obviously, that is a research challenge. You can take it up to harness that power.
Excuse me, sir. Sir, now we can refer to which reference books for each of the modules. First module only.
First module only, you just all these you have noted down the topics. You can read from different places. You can search in the you can read from that NPTEL lectures.
And sir, can you please send us slides because I am getting regularly disconnected due to internet.
No, I will send the slides. I will send the slides after certain modules are over. I will send the slides. Okay. I will send the slides. Today was the introductory. Yeah. So I thought whatever the introduction, I think it gave a good idea about electrical technology.
Thank you, sir.
Sir, we need to encourage them to start.
Thank you, sir.
Thank you,
Thank
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.